Right. One more minute.
I see some people I recognize, some people not. What time zone is everyone from?
From IST.
IST, nice.
Hard to find a single time.
Yeah, that's how I was
One.
just wondering because it's a little early for US folks, especially West Coasters. So I'm curious which time zones we got here. Sounds like IST. Do we have any from China as well? Asia Pacific time zone? Because this is borderline, I think, for them too. It's like 11 p.m.
Right. Let's get started. I think we have enough people here. Wait, wait, hang on. Did I not change the? This is the thing, right? Okay, all right. Sorry about that. Looks like I'm still in the last year. Yeah, welcome everyone. You guys can see the slides, right?
Um,
Yes, I can see.
Yeah. Okay, cool. All right. It is our first community call for 2022. As usual, I'll try to summarize updates from across the community. But we have two presenters today who are going to like demo some exciting features and stuff that they've built around Hudi. So most of the time we'll spend around that, and we'll leave enough time at the end for open floor, Q&A, anything else really. But so we do have actually quite a bit of updates. So point 10.1 is being voted on. I think the vote's closed now, but Shiva, the RM is here. He can give a bigger update on the release. We'll have an update around point 11 progress, what's going on. So far, I think it's tracking green, I would say, for a Feb release. We put together a roadmap towards the next two major releases and like our path towards 1.0 sometime by the summer. We'll just go over that. And if you haven't checked, there are some like Hudi blogs out there now as well. So quick check. Last month, I think we had over like close to some like 69 support issues. I think we managed to triage a fair bit of them. We actually caught up and resolved a lot of the issues that were there now as well. So, and we have some steady state in terms of the number of PRs coming in, the number of PRs we are landing, and our PR backlog. Even though it's growing, it's grown to like what it was before, but we are actually making progress, landing them faster as well. We have over 1,500 users on Slack now. That's a good milestone. And we have five new RFCs. There's a Presto connector similar to the Trino connector work. Like we don't see here. I think we revamped the BigQuery integration RFC now. More updates on that later. There's one around Flink and streaming improvements. And I think this one plans to expose a lot of the CLI kind of commands in Spark SQL using call procedures so that people have easier access to that. And we do have a lot of work going on around like indexing and metadata, as you know. And there's a RFC design out where we would be able to go and asynchronously add more and more indexes or drop indexes from a table without taking anything down. So it's a whole bunch of like new stuff being proposed and worked on. I don't know why it does this weird thing. And yeah, I think the big news for in terms of showcases, I think picked the 3 from the Uber meetup directly, even though like a few other things that I don't call out here. But there was this really good Uber meetup hosted by Uber engineering team, where there were presentations from Uber, which showed the kind of infrastructure that they've built, kind of like with Hudi and around that. And also from Disney and Disney plus Hotstar, talking about their CDC use cases. That actually reminded me of something very similar. We did kind of like similar things that we were running at Uber back in the day. And also Walmart actually had a really good talk around like actually also going into architectural underpinnings of why how having a layer like Hudi really helped them scale that like sort of like data democratization and this kind of like efforts to make data easier and simplify things at Walmart. Quickly, so roadmap. I think if there is the roadmap page here, you can go and take a look at it. Roughly speaking, we are tracking here the next minor releases, next major releases, and once this release point in .1 is up, I think we'll update this page, keep this updated. So this becomes a single page for everybody to track. Okay, what's the timeline? When is something coming out next? And what's kind of like what's being tracked on high level, right? And we try to sort of break stuff up into 3 layers. There is a bunch of stuff that is like very core to Hudi, right? Like the kernel of it, like transactions or index and like all of the lower level stuff. It's all grouped under transactions database layer. And then there is usually all the execution engine, Spark integration, Hive integration, all these layers that sit on top, right? So any work that's going on around that or plugging in. So if you actually look at Hudi, sometimes we have like functionality in the lower layer which is not hooked up into the like a particular engine. So this kind of work is tracked in the second one. And the third is like platform services, which includes anything from like Delta Streamer or Kafka Connect or any other things that we build that make the platformization of this easier. So we group this. Please free to check it out. We've listed down the next 2 major releases and then where we want to be by kind of like summer. And this could be like a good, I mean, it's hard to write like like a prescriptive roadmap for an entire year because it's largely driven by the community. Things come up and things get prioritized by other companies as well in a different way, right? But this is what we know so far, and I'll try to keep this updated as we go, as the releases come in. We'll always have clarity around the next 2 major releases and some kind of North Star. That's let me know if you have any questions around this. Cool. Like with that, Shiva, do you want to just give some updates on the point 10.1 release?
Yeah. Can you guys hear me?
Yeah.
Okay, cool. Hi, folks. This is Shiva here. I'm one of the PMCs in Apache Hudi, and I'm the release manager for 10.1. This is a bug fix release which is coming after the major release of 0.10. We were able to get around like 100 to 110 fixes in this bug fix. So mostly around stability and bugs. It spans around regular write path, Delta Streamer, clustering, or other table services. Some dependencies related issues, we were able to fix it. And a lot of SQL DML layer fixes also went in along with Hive Sync and Kafka Connect, which was recently released as well. So yeah, we had the voting going on for the past few days. We finalized the vote. So I'm just working on the finalizing the release, like docs and configs updates. By end of day today or tomorrow, in a day or two, we should have the release fully done. And then, so most of the time, when we have these releases, we spend a lot of manual efforts in doing some testing and certifying the release. So we have put in some time to build something like a integration test suite infra. It's been actively worked upon. We already have a version out there in the open source, but we are trying to add more and more comprehensive tests to it. So the goal here is to actually have an automated way to test and certify a release. So a lot of efforts being put on that. And if there are community members who are volunteer to help improve more, happy to guide them through.
Reflecting on this point a little bit as well, right? So I think Hudi has grown to a point where it's like kind of mission critical infrastructure for many companies out there now. So I think this kind of model will help us actually take the time, kind of like, put out good, strong major releases, but keep like also bug fixing and have a more regular release cadence for the more minor things, right? Because a lot of the stuff that we're building is actually in pretty active development, right? The space is like still pretty nascent relatively compared to like, if you compare it to like a database or like other sort of like technology spaces that you usually hear about in conjunction with it. We're still pretty nascent, I would say. So this is like a good start, I think, for us, because we can then go towards a more and more mature kind of like release management process where RM doesn't have to like kind of like, the release doesn't have to run their life for weeks. It's pretty hard to kind of get any one company to make that kind of commitment, right? It's at least in today's day and age where everything is like incremental, everything, it just is pretty hard. So yeah, I'm really excited for point and not one, the fact that I would say this release wasn't completely manual. There was some level of test infrastructure help on it, but I think we need to ramp that up and have more automated perf regression testing and these kinds of things as well. We'll keep working towards that.
Oh yeah, one thing I would like to call out is recently we have been seeing a lot of participation from the community even on the bug fix release, on the bug fix patches. Pretty glad to see a lot of contributions from the community.
Great, it's awesome. Cool. Now onto the major release. I'll try to summarize this as I see it, as I've seen the PRs and the various discussions. So there is, and I'll also try to talk about what each work tries to deliver. So we are investing in something we call as a metadata index, which will be essentially a Bloom index alternative. The main thing it fixes right now this PR, all these are integrated right under the Bloom index as a optimization. But the main thing it tries to fix is we have to read the Bloom filters out of the footers and write the ranges and the Bloom filters out of Parquet footers. When we try to do the upsert for very large tables, this can cause issues, right? Because you have to read from, let's say, 100,000 files. So we are moving that into its own like kind of partition in the Hudi metadata table. And I don't think it will be like as pronounced these gains for like smaller tables, but for very large tables, this is going to show some early testing with some 100,000 file table or shows about roughly 50% speed up. But I think there's still the bigger thing, there's still work in progress to also integrate. So what we've done with this is we now have added 2 partitions to our metadata table. If you look at .hudi/metadata today, there is an internal MOR table actually tracking all the table metadata. You will find one partition today there, which is called files, which stores all file listings. We've added another partition now, which is going to track all the column stat ranges, and another one which tracks all the Bloom filters. The idea here is then we can add many partitions for each column that you want to index or each type of index that you want to do. And we're just setting that up. This is, I would say the work is still in progress because we are also revisiting the entire Bloom index DAG per se, and to see if we can actually make it more efficient given the footers, the Bloom filters and column ranges are now coming out of the metadata table and not the files themselves. So there's some work going on, some work to be done, but I think it's if we can get it like out in 0.11, I think it'll improve upsert performance like significantly for some of these workloads, I think. The second major kind of aspect that we're working on is, so as we added more and more engines, and as people like started to also specialize different engines, what's happened now is the query side integration code has been like kind of copied around a little bit, and sometimes that is what leads to some kind of inconsistency where you see something is here not there. So we started a consolidation process where we've now pulled in across all engines. We're going to like we prop up another layer of abstraction where all of the core these parts will now reside in Hudi Common. And we've landed the phase 1 where we've done the timeline filtering and the file grouping. These kinds of things are now consolidated more or less across Spark, Hive, and Flink. And then once we get the Trino connectors landed once, I think we will do another pass to clean up like Trino and then subsequently Presto. And this now we are proceeding into phase 2 where we are trying to so if you look at Hudi, we use, if you return a record payload inside Hudi, we use Avro, right? So which means there could be like conversions from the engine specific Java objects to Avro and back. So we are actually adding a new merge API, which lets you fall back to that. But if you want, you can actually add engine specific, like you can write a merge using Spark Row, and you can write a merge, say same merge function you can implement on like Hives, whatever, like array writable or something, and then you'll now be able to perform the merges very efficiently and clean up some like event time, like merging by pre-combined time versus merging by commit time. These kinds of things we're trying to like clean up and standardize with these things. So I think this is going to be set us up like on a really good path where we want to add way more features, a couple more maybe query types on top of this. But this is very good because it sets us up for that nicely. And some updates on, so we've been trying to expose Hudi snapshots as Parquet tables for BigQuery and Snowflake as well, right? And I think we have POCs completed at this point. And there are a couple of blockers for BigQuery, I think, which we'll resolve. But we have, I think, you should take a look at the RFC as well. We have a pretty nice model here where the future that we imagine is you write to Hudi, and then it syncs it out to Glue or Hive Metastore, and keeps an external table up to date in BigQuery and Snowflake. We already have support for syncing to more than one Metastore after every commit. So in this model, all you need is to, let's say if you want to take an end-to-end use case, you want to like have a Kafka topic with some data, you run a Spark command and it'll make the table available across all these different engines, right? So I'm like very excited about this, and this will help as different engines, especially these cloud warehouses, as they improve their external query performance. I think this will become more and more interesting choice for people. The other large indexing work is the record level index. So today, this is a replacement for the HBase index. So it's been tested. It's a pretty complex problem. And now they're working through compaction optimizations for larger tables, because this index can be pretty big. It's as big as like every record in your table, right? So it can be like a pretty large index. So it may need compaction optimizations over compacting file listings, which are very small in the metadata table. Okay, so the other thing is moving us to data source V2 on Spark. This has been like one of the longer running things. We were fundamentally blocked on, the V2 APIs are very restrictive for writing, which means if we just did V2 API, we wouldn't be able to offer pre-combine or indexes or any of like other optimizations that we do under the hoods, right? If you currently do df.write.format hoodie, it does pretty much like a lot of different things for you, right? But we lose all those with the V2 API, so we didn't really like go for that. But I think the other formats, I think have like I think have actually hit pretty similar problems, I would imagine. Now there is like a fallback layer path to make V2 fall back to V1. So we've implemented some PRs and we're getting on our way now where we'll retain the V1 writing path, but we get to use all the V2 APIs for the querying and also like writing in some sense. So this is a pretty good setup, I would say. We already have a kind of an initial PR for row writing. We now have actually two parallel efforts. One is getting the existing data source working with V2, while parallelly trying to refactor the code so that we can land row writing end to end under that, much easily. And finally, some Presto Trino updates. I think we've landed all but one PR for the Hudi support inside the Presto Hive connector. And the Trino connector is code complete. I think we're gonna like raise the PR. I think pretty soon. We at least like reviewed this one pass within the Hudi community. And then the Presto connector is under review. I think it's already been running in production. So I think hopefully, we'll have a quick path here. I think with all this, I would say after 0.11, we'll have like, we'll have like a very, very solid foundation. I feel I'm really excited for this release. Cool. All right, over to you, like feel free to, I'll make you the host or
Yes.
something like you can grab.
Can I share the screen? Yeah, thank you. Host disable participants screen sharing.
Yeah, I made you host now.
Okay. Yes, got it. Yeah. Can you guys see my screen?
Got it. I can see.
Okay, cool. Okay, thanks, Vinoth. So I'll be presenting Hudi plus DBT integration today. A little background on me. I'm from Uber's data infrastructure team. I work on derived data sets, and I'm working on initiatives where converting or creating more incremental data sets using Hudi on derived landscape. Okay. Here I'm going to talk about a few different things. First, I'm going to give a brief introduction on what is DBT and what role it plays in the modern data stack. And I'm going to talk about the architecture of DBT and then touch upon Hudi and DBT integration, how it became possible and how it is integrated, and finally end up with the demo. First, let's talk about what is DBT. DBT stands for Data Build Tool. It's an open source transformation tool that allows anyone comfortable with SQL to author data pipelines. It's a simple tool to build complex pipelines. It provides the SQL compilation layer in the ELT model, and it follows best practices from software engineering like linting, peer reviews, don't repeat yourself principle, and data quality testing is embedded along with documentation and support for CI/CD. for your data pipelines. And it uses SQL in a rich programming environment with the support of Jinja templates, where you can define, you can write SQLs. In the SQL, you can define if conditions, for loops, as well as you can call a macro. That's why they implement the don't repeat yourself principle, where commonly used functions are created as macros, and there are a lot of pre-built macros available, which we can use. On top of that, you can define your own macros. And it uses, whenever you are referring to a table, you use the ref model. Based on the ref model, automatically it creates a data lineage, the table level lineage across your models. So the lineage graph is built for you from your actual model code. And there is a documentation site built as part of the tool, where it lets you see how your models are interconnected with table level lineage graph and other documentation. And it has a huge community, open source community, over like 24,000 folks in Slack. And it also has a cloud offering, but DBT core is free, and you can use it in your organization. What is the DBT architecture? So as you can see in this picture, where from the data loaders, for data loaders, we can use any external loaders like Fivetran, Airbyte, Stitch, or even like for streaming data, we can use Delta Streamer, which will do the data transformation, which will do the pulling the data from sources like Kafka and other sources, and it ingests into a raw data table. Once you have the raw data, then what DBT provides is provides a snapshot query approach, as well as it provides a transformation feature with SQL, and it allows you to write test cases, tests on for your data, and you can deploy using CI/CD model, and it provides documentation out of the box. And everything is version controlled, and there's a metadata layer API. Using that, you can get alerting, logging, all those things. And finally, you can write those into it provides different varieties of materialization, table, view, and intermediate tables, so that you can perform your transformations. Once you transform, you can use BI tools and data science to actually query that. Let's dive into how Hudi is sitting in this architecture, where if you use Delta Streamer to load the data into raw data, then all the tables are already in the Hudi format. Then you use DBT to actually transform those raw data into derived data, and you can write back into your cloud warehouses. Analysts can actually write select statements using DBT, which DBT will convert them into tables and views for your data warehouse. This integration became possible after the release of SQL DML support from Hudi. Once you have that, then all those transformations, we wrote a transformation query translation layer from DBT's SQL semantics to Hudi's, so that you can create tables, as well as Hudi provides asset transaction on top of it, where it supports update, merges, deletes kind of primitives, as well as DBT provides a complex transformation layer on top of data warehouse. I'll dive into a demo where I have a local Spark running. So I have a local Spark server running in a container, along with Hive Metastore. And DBT, normally you use, when you're using from your servers, you can use the command line. The command is DBT, and there are multiple options available for DBT. where now it shows the ls command shows the list of models available in my repo, and the dbt run is going to actually run the models. The run will take 1 or 2 minutes. I'll start the run and I'll explain what is behind this run. So any dbt project starts with a profile, dbt project.yaml. There you are saying what is your project name and what is the profile you are using. The profile could be Spark or BigQuery or Redshift or Snowflake. All those things are available, as well as in the profile you can specify whether this is a dev profile or this is a production profile or staging profile, based on which automatically it chooses which database to choose and what connections to use. And similarly, all these profiles are defined in your dbt spark.dbt.yaml, which is in your home folder. So I have only one profile defined, which is local, but you can define multiple profiles. Once you have that, and then you can specify where is your models. My models is in models path. Models are nothing but the select statements which forms the derived tables. And similarly, there are other paths for test, seed, macro, snapshots, and other packages. And for your table, you can say where is your, like, what format you need to use for your tables. Here I have said Hudi as my default format, so that any tables I create using this profile, it's going to be a Hudi table. Once you have this project.yaml, then all you have to do is create a model. A model creation starts with the YAML file. In the YAML file, you define the schema of the table, where you say that this is my table name, and this is the description, and these are the columns. While you're defining the columns, you can also specify the column name, description, along with test. What are the tests? There are some predefined tests available, like unit test, not null, and you can also define a query here as a test, and that will be run when you are running the dbt test command. You can check the differential and constraints, and you can also write custom tests. Similarly, I have a bunch of models in my table, each demonstrating a different materialization offered by Hudi. And if once you have this, then all you have to do is define the actual model. In the model, you can say what is the type of materialization you want to use, whether it is incremental materialization or it's a table materialization or it's a snapshot materialization. You can choose that. And what is the strategy you want to use for merging, whether it is upsert using merge, or it's using insert override or insert. And what is the file format? I have already specified the default file format, but you can also override that here in the config as a Hudi. And for Hudi tables, after the latest release, the primary key is a required field, so you can define that here. And you can also define what is the, if you are updating only few set of columns, you can also specify the merge update columns as a list of columns here as well. Similarly, for this is not a required field, you can leave that as well. Then it will do a full merge on that table. Similarly, for upsert, you can also specify other Hudi options here, whether it is a copy on write table or a merge on read, and what is the primary key and what is the pre-combined key as well. You can specify that using options. And if you want to set some Spark configs, you can set using the pre-hooks, where before running this model, it's going to set this pre-hooks. Let's go back to dbt run. Since I have it started the run before a few minutes, it completed. It founded 10 models in my repo, and with 18 tests. And like there are a few macros which are pre-built macros. As you can see, if I say dbt run, it's going to convert those select statements into, compile those select statements into actual queries. And it's going to perform that operation on Spark, and it's going to create the data set in our data lake. as you can see here, this is the folder in which I created all the tables. You can see all these tables are Hudi tables. Some are partitions, some are not partitions, with Hudi metadata as well, .Hudi metadata. Let's dive into the document section, where you can say docs generate command to generate a document, which is going to use your model.yaml and generate the documentation. Once you have the documentation, then there is a built-in server available to serve the documents. If you say dbt doc serve, then you get a nice documentation page where you have all the models which you have defined. And for each model, you also have the list of columns, the description, and bunch of metadata around it, and how big is this table. Similarly, like I was mentioning, the SQL will be compiled. So this is the code which you wrote for creating this model, but this gets compiled into a code like this, where it uses the select statements on that. And similarly, for upsert table, you can see some of the statements for merge. It converts those. Here you have defined if it is incremental model, use this. If it is not incremental model, use this, which got converted into the corresponding statements. The merge statements, I can show that here. So when you have a when you compile it, it goes into the compilation folder in the target in the compiled, and when you're running, it goes into a run folder, where you can see it converted the select statement into a merge statement, merge into this table, and it created a temporary table, and using this merge key ID is the primary key on that table. And when matched, update all. When not matched, insert all. Similarly, for update on specific column, it will update only, when matched, then update only the message. And when not matched, then do a full insert. All these conversions taken place in the dbt. Similarly, for your, as I mentioned before, there is a lineage graph built in. If you click on go to a table and click on this lineage graph, you can see the full lineage graph of that table. From this table, from insert table, there is another table created called insert override table. From the insert override table, I have created upsert table. From that upsert, there are two tables which are created: upsert partition, MOR plus and copy on type table. And from here also, you can explore back to that. You can go back to that node, and you can view the documentation for that. And here it also specifies which table your table depends on. It depends on the upsert table. Similarly, for each column, there are tests defined. You can also see that, see those tests as well. To run the test, I have not run the test before, so I can start the test here, where dbt test is going to run the test for that. Once you have the test, you can also see the test results here. That will be showed up, that will be populated in this section, and you can click on it and you can see what are the tests which ran on your model. Now, some of the tests are running here. There are 18 tests available, and all these are against a bunch of Spark queries on that table which we created. And you can also see for the first time, it creates a model. It creates create table as statements. The next time the table exists, then it uses the select statements and merge and other statements to populate the table. So it's running. Once you have run, then you can see the results here. Similarly, there are multiple other views and there are searches available where you can search for name, description, columns, equal, and tags as well. And you can also specify a bunch of other metadata in your schema file. Based on that, it will be populating here as well. Yeah, that's all I have. Any questions?
It's amazing, Vino. I had a question or two. Does it work with the Delta Streamer too, or are you're defining these and then you can run in Spark context or?
Right now, it doesn't work with Delta Streamer, but that is in the future work where we are going to. Right now, it is using incremental. It is not using pure incremental, where it loads each partition, partition by partition. But with Delta Streamer integration, you can actually do a delta processing from what it already processed. For that, there is another request we need from Hudi end, where using SQL, I need to know what is the last process. Fetch me the records from since last processed using Hudi command. Once I have that feature from Hudi, I can integrate that with dbt as well.
Nice, cool. Is that in the path for 0.11 or coming up?
Yeah, mostly for 0.11, we can target that. Yeah.
Sweet. This is super cool. And that, because you said you can only do snapshot queries right now. You can't do incremental queries.
We can do incremental queries as well, both snapshot and incremental.
Okay, nice, nice.
Yeah.
But I guess you need something to track the checkpoints and all of that once you made the pipeline itself incremental end to end, right? So what dbt offers is ability to do incremental models where you can merge and like update, but you still have to like track from how do you extract the new change sets upstream to observe from, right? So if you look at Delta Streamer, that's what it gives you. It gives you, for example, for Kafka or like S3 or anything, it gives you a checkpoint from which you can consume new data, apply it, write it, transform it, and then it tracks the checkpoint. And then every time it fetches the checkpoint back before it goes to the source. We need to do something like that. DBC has like good kind of tooling around the manageability aspects and building and maintaining these pipelines. I think we need to like Hudify it a lot more, this model. Then it can be very, very powerful for building incremental pipelines, I think.
Yes, exactly. Yeah. For other models, for other data warehouses, it has the support where you can say it already tracks what is the last completed checkpoint. From there it uses, but that has to be translated for Hudi. For other things, here you can, for incremental, you can say that there is a var class you can add where last updated, and you can provide a macro. For other data warehouses, they are providing it. We just need to add the support for Hudi.
Super cool.
Yeah. Since the tests are done, now if you go there, you can see all the tests as well. I just want to finish with that. And now you can see there are some tests available. Tests you can see here, and in the test as well, you can see that.
Cool.
The test, you can see the test, and you can how that tests were run. For not null check, this is what you're checking. You can also see that.
Okay. Cool. I think this is very cool. If there aren't any questions, I think we should go to Harsha and talk about another exciting integration on like Airbyte. Let me reclaim, then make you the host, Harsha, and then you should be able to share, I think. Sorry, we are in this budget plan on Zoom. And we can go a little bit over if you're comfortable with that. So
yeah. Can I share now?
Yeah, you
Okay.
made a host.
Okay. Okay, my laptop, my Mac is saying I have to give permissions. One second.
Yeah.
That means you might have to restart the app and rejoin.
Yeah. I had to rejoin.
Yeah, no worries. Let me reclaim. Once you're in, I'll hand it back
Sure.
to you.
Yeah.
So while we wait, I think we know if you can like make sure there's a 0.11 blocker around this part. I think we can get that in. That will complete this DBT story for us, I think.
Yes, yeah. There are a lot of people in the DBT community also interested in this. So they are using this on AWS cloud, where they already have DBT for their data warehouse. Now they just want to make it work with Hudi. Yeah.
All right, Harsha, you have your host again.
Yeah. Okay. Can you see the screen?
Yeah. We see the command font.
Okay. Give me a second. Okay. Now you can see.
Yeah, the browser.
Okay. Okay. Yeah. Myself, I'm Harsha Teja Kanna. I'm a software engineer based out of Dallas. Recently, I've been working on adopting Apache Hudi at our organization. I found the interest into it and tried to make it more easy to adopt for various teams. So I was looking at basically I want a nice UI on top of Hudi to make creating Hudi tables smooth and more automated. So I have experience with one framework called Temporal, which I used to develop, basically data pipelines and infrastructure automation. So Airbyte is based on that framework. So I immediately took interest into see what it is about. So Airbyte, it's an open source data integration platform. Basically, it connects sources to destinations and move data between them. It has a lot of open source connections. Almost all the open source databases. And these are highly extensible. We can develop connectors in different languages. Actually, Python and Java are supported, and others are planned, I guess. So, and there are destinations where all the major databases has destinations, and it's pretty exciting, and its community is very huge, and and they are very helpful as well. So why Airbyte is like, if you see the source and destinations and the databases, and if you see Apache Hudi, they are kind of similar. Like Hudi also has data sources, and ultimately the destination is lake storage. And okay, I'll first open, I have to explain a little bit of features of Airbyte to make it easy. Why it will be be a good match, or better fit for Hudi. So let's go and see. This is Airbyte UI. Once you log in, you will have connections, sources, and destinations. I already added 2 connections basically, or I'll show. I have added a source, which is a cloud storage S3 bucket as a source, and also I've added 2 destinations. Again, both are S3 cloud storage destinations. So connection is a way to move data from source to destination. So we can actually create a connection, select a source, and then select a destination. And by that way, we can set up a connection between them. And the beautiful thing about Airbyte is it provides catalog selector. Basically, what happened when we set up the connection is Airbyte created a source connector, and it fetched the files. Like it looked at the schemas of the Parquet files that are in the S3, and it listed on all the fields from those S3 Parquet files. So it's like you can select what columns we want to end up in destinations once the sync is done, and we can select different modes, like whether we want to fully replicate the table or whether we want to incrementally append each file, and we can select at different intervals where we can run the sync between source and connection. And it depends on source to source. Like, because this is not a database source, we don't have primary key and cursor field. But if it's a database source, like it will have these populated as well. So that is why I was interested, because almost the work I'm doing with Hudi is similar, right? Like with Hudi, okay, let me show the small slide. It's a very informal slide. I'll show. So, okay, by the way, this is experimental integration. This is not like a preferred or, approach or that the connectors are developed with Airbyte, existing Airbyte. So I'm just proposing it as a way to extend Airbyte in a new way, so that it will be beneficial to Airbyte community and both the Hudi community as well. So what I've done is simple. Basically, map the configuration of Airbyte and add a extra configuration called replication configuration and map it onto Hudi config. That's all. That is what it will sum up to. So if we go into deep, like the mapping can be like this. In Airbyte, there are like source configurations which are populated from JSON schema that comes from source connectors, and it maps to basically Hudi DFS route, basically the source of the input partitions files. And the destination config will map to the target path and the table name properties of Hudi table. And the catalog maps to transformer SQL. Basically, the stream and the columns that we pick from the Airbyte interface, they can directly map to the columns that we pick in transformer SQL of Delta Stream tool. And the sync modes, like full refresh, override, they will become Hudi operations. Basically, create a Hudi table and do an insert, or do an upsert on existing in an incremental fashion. So it maps onto those operations. And the resource requirements, there is no direct mapping, because Airbyte is based on containers. The connector source and destinations are created as containers, and Hudi will run on execution engines where there is no direct mapping between resources, like Spark executors or driver memory and CPU. But we can build a mapping through the configuration. And finally, we need a replication, extra replication configuration that doesn't exist within Airbyte configuration, to map into the actual additional services Hudi provides, like clustering configuration, cleaner configuration, and what metadata and other configuration. So this will be a new addition to the existing configuration. And what I've done is to make it easy to configure this. I have followed the same principles of Airbyte by making the connectors as Docker container, Docker images, and declaring a JSON schema for this replication configuration, so that we can gather the configuration from UI and pass on to the backend orchestration process. So yeah, so that is how this configuration will be mapped. And for example, as I said, like we'll see here, this is the new UI I have built, and it is dynamically picked up from list of connectors, replication launchers I'm calling them. I've added two of them actually as of now. One is for AWS EMR. Basically, I run Spark on EMR, and the other one is I run Spark on Kubernetes. And both these are individual Docker images. They can launch as independent workers within Airbyte, and they can orchestrate the process. For example, if you select K8, it provides the JSON schema mapping to the UI. Basically, it asks us for selecting the operation and source ordering field and table type and different classes. What are all the Delta Streamer configuration we need to pass on? It will pick up from here, and all of them have defaults that will be mapped from whatever information that it can gather from source, destination, and the catalog. If there is no mapping existing, as I mentioned before, we can provide those entries here. That is how we configure correction. Okay. So I'll show a few like the example executions of the replication process using both the connectors. For that, I already created a source, that is, as I said, S3 source. I'll go. It's an example Parquet file. It's a very tiny Parquet file just for demonstration purposes. This is one Parquet file I created. This is the source basically for the Hudi table. And then I created two destinations. Both are again S3 paths, basically S3 configuration. I've added them earlier with this configuration. And we'll create both the tables. One is with K8s and one is with EMR. So as I've shown before, like I have created two connections. One is from this source and to K8's destination, like K8's execution table, and one is EMR. Let's first run the execution launcher that runs on K8's. So this is the interface where we run the replication. So it provides a nice it's similar to like other like orchestration. For example, in Airflow you have similar kind of UI where you can run DAGs and you see logs coming up in the UI, right? It's similar. So for example, if I say hey, sync between source and destination, it should create a Hudi table, and we should see progress here.
So they started a Delta Streamer job?
No. So what's happening is, can you see the screen?
Yeah.
So I stopped the replication launchers. They are not running yet. So the sync is not scheduled yet. Okay. Now what I'll do is I already built the worker that runs the K8 sync jobs, and I'll bring that up. So once we bring that up, the job that got scheduled will be routed to this particular worker, which actually listens on a queue called K8's queue, which is derived from the Docker image itself. Okay, so something is happening. Yeah. So if you see, once it came up, it picked up the job and it mapped the configuration, and it created the Delta Streamer and it configuration, and it launched the Delta Streamer job. Here is my Kubernetes node, basically cluster that is running the Spark job. So I'll show in a moment on how this is invoked, but we can see that a Spark job got kicked off, right? So we can see the progress here. It shows basically this is the mapping we created that got created from the sync input and the replication configuration, and it is finally in a stage saying, hey, that you see this is the executor that is running, and it is saying, hey, executor is running. Basically, this is the same executor that is running. We'll wait for a bit for this job to complete, and it should create the Hudi table in the destination path. So this is run. This basically the image and the container I'm running is basically a temporal worker. It is an independent service. It doesn't from already existing Airbyte workers. So basically, this is like out of process and out of we can say microservice oriented. So it does this does not impact other workers that are running other jobs within Airbyte. Yep, I think the job got succeeded, and we see the executors are getting terminated. I think Hudi table should be available for us in location. I will refresh. Yeah, test. This is the Hudi table that got created from that job. So now I'll show the other kind of worker for a different connection. So this is basically this sync connection. It has replication configuration that is configured to call to an EMR cluster basically. So let us sync this again and see what happens. I started a replication from the same S3 source and a different destination name for a different Hudi table name. Again, a job that is scheduled, it is not running because I did not bring that worker yet. Let us bring that worker. This is a different kind of worker, which is based on AWS, and it basically communicates. It's a basically API based client calling EMR service. Yep. Again, it created the Delta Streamer configuration, and it mapped the configuration onto configuration, and it created a EMR step. Basically, you can see that EMR step is pending. EMR, it gave us back a status step ID. We have a new step ID, and the status of that step should be getting tracked now. We'll see it refreshed. See here, we have a basically is EMR step that got created that corresponds to the connection basically. Let's wait for a bit. It is still pending, and we'll track. Yeah, it is tracking the progress here. So meanwhile, while this is going on, I'll go a bit deep into how actually Airbyte replication works. So this is how Airbyte replication is implemented. So this is the worker I'm talking about. It's a process or a container, we can say, which polls for jobs, sync jobs, and once it receives a sync job, it will create a container orchestrator. Basically, it's again one more container which calls out different container engines or orchestrators like Docker or Kubernetes. So here, for example, I've shown a Kubernetes example. It's a pod. Within that pod, a container orchestrator is running, and it created two containers. One is source container and destination container. So how Airbyte is implemented is these source containers and destination containers are like extensions or plugins where contributors can contribute to the Airbyte project, which actually deals with communication to the source and extracting the records and discovering the catalog from the source. And ultimately, it also has commands that will read the records and pipe them into basically standard out. And once this container got started, it will also create a destination container which has similar implementation in the opposite direction. Basically, this container will receive the records on the standard input. So the container orchestrator will basically read from source pipe and will forward it to destination pipe basically. And meanwhile, source manages state, and it knows has knowledge about how many records are processed. So that is kind of different when we do it with Hudi basically. So this is how it is done. So once the sync is done, it will give an output back, and worker will try to finish the I will communicate back into database, and it will have the sync state persisted. So now comes to Hudi replication. It's similar, but kind of like I have to extend the model. So I have created a concept called Replication Launcher, which basically gets the sync input from the worker as earlier. But this worker is the worker I have shown. Like we can develop multiple workers which are independent. Like one is for EMR and the other is for Kubernetes, right? It has a piece of code called Replication Launcher, which actually delegates the process of replication to Delta Streamer. In the sense, it will extract the configuration sync and it configures the Delta Streamer. That means it maps the source config and destination config, and it will create a Delta Streamer pod basically. This Delta Streamer pod will invoke ultimately the Spark driver and executor, and it will run the job to create this Hudi table. Once it is done, this replication launcher has a monitor method which keeps on monitoring the state of the Delta Streamer, and once it is done, it will forward the state to the worker, similar to a Byte replication. So replication launcher will have configuration to communicate with, say, like EMR or or Kubernetes or any other cloud provider. That is the config that we have to provide. Yeah, this is in high level view. I have code that I can go through, but I think we are short of time actually. But okay, let's see if if you can see there is one more Hudi table that got created, and yeah, that is also completed down here, and we have successfully synced. So what what made me explore this is basically I want to achieve an easy way of creating Hudi tables and perform the orchestration from Airbyte itself without any external orchestrator. So this is kind of what I want to try to accomplish. Basically, first of all, extract the data set from a database or a stream like Kafka or any external from Airbyte, and basically stage them in a raw storage layer, and then again perform one more sync within Airbyte itself that will actually create the Hudi table from the intermediate source to the ultimate source destination. So in this way, we will not have any other orchestration needed to create Hudi table, and that makes, I believe, adoption and ease of use for creating Hudi tables. Yeah, that's almost like there is more I can go through, but I'm not sure what is. So I can actually go through actual code implementation, where I have a new section called Byte Replications, where the code is categorized into libraries and workers, and a protocol layer, where the protocol layer is actually the contract between Airbyte and different kind of workers that we will implement. For example, here I have like KX worker and AWS worker, and they implement a protocol called what I'm calling is Replication Launcher. This Replication Launcher is very similar to the connector specification Airbyte already provides. It has similar functions to extract like the specification or like a JSON schema of the connection, check the status of the connection, validating the connection, and it has a launch method and a cancellation method to basically invoke and handle the cancellation of the sync process. So if a worker provides implementation of this interface, any replication launcher can be used. Why I did this is Hudi is not like a direct destination in Airbyte. It doesn't map to one because Hudi itself is a platform, right? It has its own layers and source and destinations. So we may need multiple combinations. Like Hudi can run on Spark on AWS. Hudi can run on Flink on Alune, or Hudi can run on Spark on KX. Hudi can run on Flink on KX. All those combinations. So for all those combinations, we can have different workers which can provide the functionality that Hudi supports.
So this is cool. I think just a quick time check as well. I just want to make sure we also have some time for questions if there are any. Around Airbyte, I think, so I can go first. I think this is like a great start. And if you're interested, we can start an RFC to just flesh out a lot of these other things.
Mm-hmm.
I think especially on running table services, async versus inline, how do we get the scheduling? So just to, it'll be good to kind of like soundboard and get that sort of deployment fleshed out end to end. That'll be awesome. But this is like a pretty good start, I think. Thanks for plumbing through a lot of this, like a lot of details. I think you figured out and build some proof of concept here, which is great.
Yeah.
It's amazing, Harsha. It's inspiring to see. I mean, my question was going to be like, how can I try it out? How can I get my hands on it? What are the next steps to make it possible for others to use it? So I don't know if that RFC is the right next step.
No, actually, I'm. So even I mean, first of all, this is like experimental and my personal and side project. So first we have to propose this to Airbyte, and they need to accept the thing I'm proposing. So that is the first step. Once that is crossed, only then we can go ahead, because there are a lot of changes, right? Like there is a new concept being introduced, and if you see a Airbyte implementation, it's different. It doesn't match this. So I'm trying to communicate with them and give them an initial overview of this. First of all, I have to create an RFC for Airbyte based on this, and we have to see from there how it goes on.
So cool. Look forward to hearing more progress and next steps.
Sweet. Any other questions? We can go to general Q&A.
One question. This is great, Harsha. So one question is like, so all the changes are required only on the Airbyte side, or are there any changes required on the Hudi side?
No, there are no changes required on Hudi.
Okay, good. Thank you.
Okay, now I'll stop sharing the screen.
Right. I think we're over. But any questions for general Hudi questions? We at least have, I see at least two PMC members here and some committers, so we can also answer some questions if you guys have, or fire away. If they're not, then I think we are at the end of our thing. All right. Thanks.